So as a reminder, we heard in the earlier section of this tutorial, we heard about the Aria Research Kit, which really enables anybody to get their hands on a pair of Aria glasses and access the machine perception services that we described. The open science initiatives are really to enable people without devices to be able to benefit from the Aria research program, whether that's accessing open source data sets, open source tools, or open source models. So let's take these through one after the other, starting with open data sets. As a reminder, last year we released the Aria pilot dataset. This was the first dataset that spanned the entire sensor suite of the Aria glasses. And not only was that the entire sensor suite, that also included some of the annotations that we described earlier, whether there was rich automatic annotations from things like machine perception services or manual annotations on top of those. So for example, we had per frame poses for all of the sequences in those data sets. We had time-aligned sequences between sequences that were captured simultaneously. And we had things like speech to text so that we could open up opportunities to explore challenges in contextual AI. And the dataset was separated across two different types of domains. The first was across everyday activities, which were captured by actors, essentially role-playing some of the scenarios that we expect people to see throughout their everyday environment. And of course, where there were sequences that were captured in the same frame of reference, those sequences were then aligned to the same space-time reference frame. The second set of domains for the Aria pilot dataset was this desktop activities. Essentially, this was a Aria wearer surrounded by multi-view cameras so that we could explore challenges with object detection and tracking tasks. And one of the interesting outcomes from this first release of the dataset was the segment anything model by the Meta AI team actually used this dataset and used the eye gaze as an input to their model. So that was last year. This year, we're very excited to announce two new datasets. Those are the Aria Digital Twin and the Aria Synthetic Environments dataset. I'll take these through just a high level, one after the other. The Aria Digital Twin dataset is, we believe, the most comprehensive egocentric dataset with a high quality corresponding ground truth. What do I mean by that? Well, in this video here, you'll see in the top row, we see the real world footage as it's come directly out of the Aria device. In the row below, we see the simulated ground truth. Essentially, this is a synthetic copy of the real world that we can use for interesting research challenges. In order to build this, we had to accurately digitize the entire space, as we can see a fly through here, which involved LiDAR scanning the environments and then doing manual tweaking to make sure that the synthetic digital twin is as accurately aligned to the physical world as possible. We'll hear a little bit about how this was captured later on from Carl. What this allows you to do is then to take those annotations and propagate them back into the real world footage. So you really truly do have this comprehensive ground truth of the real world. That's Aria Digital Twin. The second dataset that we're announcing today is Aria Synthetic Environments. And this is the first procedurally generated synthetic Aria data for large-scale ML training. What do we mean by large scale? Well, what you're seeing here is just a snippet of one of the 100,000 synthetic scenes that we use for scene reconstruction tasks. Taking a look at some of these trajectories, we essentially have 100,000 unique scenes where we're simulating Aria trajectories throughout those environments to make sure that within those sequences, the observers are looking at every single part of those scenes. And of course, because this is entirely synthetic, we have comprehensive ground truth that we can also use, whether that's the RGB image, the depth map, or instance maps for those same environments. And uniquely with the Aria Synthetic Environments dataset, we also have this CAD-like language that is able to describe the scene using something that's equivalent to architectural commands. So we have something like make wall, make window, make door, describing exactly how that room is laid out. Now, for these two challenges, for these two data sets, we have two challenges. So for the Aria Digital Twin, we actually have two different challenges. We have the 3D object detection and tracking task with scene generalization, and then a second challenge on top of that is few shots 3D object detection and tracking. The difference here being that for the second task, we don't include the objects that you're trying to track within the training data. For the second dataset, the Aria Synthetic Environments dataset, we have a scene reconstruction challenge that requires you from seeing a sequence and then translating to that architectural language that we described before. So these are the datasets and challenges. Please do have a look online at projectaria.com and have a look at those datasets. But this isn't, of course, just about us from Meta building these datasets. This is also about enabling the community to use Aria, capture datasets, and make those available to the wider community. So in order to do that, we have this second pillar of the open science initiatives, which are open tools. We really believe in accelerating the state of NP and AI research and believe that we can do that together with the community. I'm not going to repeat some of the material that we've seen earlier on today with the open source tools that can be used to dig into these data sets, but it's not just about the Aria data sets alone. We're also releasing tools that are valuable outside the Aria ecosystem, such as VRS, the file format that we use to write out time series data, whether that's from Aria or our Meta Quest line of devices. So do please have a look at that on GitHub. So those are tools, data sets. Finally, open models. And when considering which of the models that we use internally we actually open source, it took us back to why we produced the Aria program initially. This is really about how we can demonstrate responsible innovation, and responsible innovation starts with privacy. Prince mentioned that the pipeline that we use for data collection that is outside in public spaces goes through an anonymization pipeline to obfuscate faces and license plates. What we're doing in the coming months is that we are open sourcing this model so that if you are capturing data, whether that is with Aria or any other type of device, we can anonymize that, obfuscate faces and license plates to ensure that the researchers are actually focusing on the work that we need to be doing rather than having to reinvent the wheel. So those are the open science initiatives as part of the Aria program. We've got data sets, we've got tools and models, and this really is just the beginning. So we're really excited to bring everybody along for this journey with us. Please do have a look on our website and sign up for a newsletter at projectaria.com/newsletter. And from that, we'll make more announcements about tools, challenges, models, and data sets in the coming months. With that, let me please hand over to Carl Wren, who's going to take us through a little bit more detail about the Aria Digital Twin dataset and challenges. Carl.